I had a pretty weird last month working with different technology, and I wanted to share with you something that really grinds my gears. So I wanted to say a few words about error handling. Thanks to Jem for coming up with that title. How do I, oh yeah, it's not synced, whatever. My name is Eduard Kyvenko. I'm from Ukraine. I work for TV2. Talk to me about functional programming. Yeah, that's my GitHub. So, what do you think is the biggest challenge for a React developer? I don't know, like, if anybody feels like taking a shot, yeah, that's. Don't spoil it. Yeah. Yeah, that's true. And well, really, there is. I mean, not to devaluate your answers. There are many answers to this question. There is state management. There is everything. Like it's async programming, and of course error handling. And I mean, I'm really surprised nobody mentioned caching and naming. That's really a bummer. So the errors, thanks for the spoiler, in case if that wasn't obvious. So to start talking about errors, I feel like it's kind of useful to go deep to the roots. We obviously have React and it's nice, but what does JavaScript and how it works? What principles people used when they designed JavaScript? How they intended the error handling to be. So sometimes JavaScript just returns some kind of nullable thing if it can compute the thing. So it could be a null, undefined, not a number. Well, on top of that, it could throw if like the input in some way is invalid. So in case of query selector, if you pass an invalid selector, that will crash, which was a big surprise for me. Not that big, but. So, nullable. Is this even a way of error handling? Was that ever an option? Have you ever done that? Maybe, and it's a way to go. I mean, there are some good sides. It obviously provides zero context about the error. We don't know what happened. Like something happened. If you're really worried about the return type, of course it's going to be inconsistent. Does not change the control flow. It's kind of an okay way. And according to the creator of null, you will lose $1 billion, obviously. Which is a questionable statement, but whatever. Then there is throw. Throw is almost always implicit. What does that mean? You never know when things throw. You never know what things will cause the function to throw. Something causes things to throw, and then you just experiment or read the docs in case, if there are docs, and then you sort of discover that things are throwing. And catching is not really straightforward. Sometimes you can catch, sometimes you just can't because it's async. It's not very reliable. Because there's no clear practice on where exactly to catch errors. That's the last point. So on top of that, it's hard to compose. Pretty much the problem of async await and try catch is described here. If you ever need this ID, it's inside of try block, then you need to define variables outside of this block and whatever. It's not really great. And lots of boilerplate, of course. Well, try catch, never been nice. This is how I see try catch sometimes in the apps when we run just, well, let's go with the entire code base and then do a console log on maybe nothing. Then there is promise. Promise is an interesting beast because it actually is isolated, does not bubble like thrown errors. You never catch random errors in some places from promises. Well, unless if it's an uncaught promise, but let's pretend it's not there. It's a very good choice for graceful shutdown and recovery. It composes well. You can run multiple promises. You can change the data returned from promise. You can change the data returned from catch. Really nice option. There's only one problem with it, really, which is not really a problem. It's kind of part of the spec that promises have to be async. So if you run any code, like we can't use promises for synchronous stuff like parsing JSON. Well, the last option really is a node back. It's a concept, if you've never heard of it, it's a concept popularized by Node, and probably you've used it, maybe you haven't heard the term, but it's called a node back for a reason, because we obviously pass a callback where the first argument is an error, and then we check for an error, and then we know that bad stuff happened. That's node back for you. So on my scale of complexity, by no means you have to agree with this, I rate those things from the simplest on the left to the most complex on the right. So here we sort of have the selection of tools we can use to handle errors in our applications. And if you look at the situation with how they work, for example, nullable, it's always sync. Try catch is also always sync. It does not really help us with async stuff. And try catch kind of sometimes provides us context. Same case here. But then if we look at node back and promise, those work really nice. They give us an actual error where you can have a full control, whether you're an implementer of a library that throws errors or no matter what you use, promises or node backs, they're all fine. But then what if we're going to look at TypeScript? Like, why TypeScript doesn't do anything about exceptions? And there has been like a proposal for 3,000 years open on GitHub. Like nobody even cares about it anymore. It's a proposal about the throws directive, which was intended to do something like this, where you can define in your type signature that the thing sort of throws this kind of error. If you've ever used Java, anyone? This must be familiar, right? And it's kind of a useful feature, and I feel like it might be a very valuable addition to TypeScript. But yeah, there's a lot of attention to this. But this entire discussion is followed by like a complete essay on like why this is not supposed to happen. And I've read it all, and here's the scoop. So according to Anders Heilsberg, the throws directive introduces breaking changes when a throwing function changes the exceptions it throws. And I mean, you could argue that it's kind of an official position. It's an opinion. It's not like a fact. It is maybe doing that. That's the reason basically why they're not there. It sort of obstructs the optimistic path programming. So you sort of have to do something about these exceptions. And top level catch is, well, if you intend to do something with all these exceptions, and if you have a lot of functions throwing exceptions, then you apparently need to know about all these types, and it becomes really complex really quickly. And it's all on opinion. We don't have to agree with it. Well, I don't. Because in the parallel universe, here's a man doing something completely different. They use a language which does not have exceptions. It does not have the concept. Every error that occurs, you have to handle. You don't have an option of not handling the error. And I mean, the number's pretty big, whatever. I mean, the idea is that there are no runtime errors because all the errors are handled. They don't have to be handled in a super cool way. They might be logged. There might be some kind of error screen, but as the developers of the UI, we exist in a different domain, and that's not the domain that shaped this entire C# culture, where, well, we just need to go to the optimistic path because it literally impacts your user. Your errors not handled, it's just it ends up literally on user's computer, not providing a proper user experience, which is pretty horrible. And we sort of work with this culture that sort of is coming from this server-side oriented programming. So controlled errors make your runtime stable. That's pretty much the idea. Before I'm going to introduce the new NPM packages, I really wanted to do something different. I don't really want to make an NPM package to fix this, because this has been fixed before the NPM package, before it's... So I'm trying to attempt something a little bit different. I'm trying to introduce you to a pattern instead of an NPM library. So what if we did something like that? If we had a function where we pass the actual function and then the arguments, called it, and then sort of returned something that's called, well, you can pretend that it's a tuple. It's actually an array of 2 elements. And since JavaScript now supports destructuring, you can easily extract those and check whether the error happened. Same approach works really well for promises. So we can check whether it's a promise. We can even check whether the function creating promise throws. So in that way, we sort of prevent the error all around, and we get something out of that error. Well, surprise, it's actually, yeah, well, there is a repo, and it's a library, but which you don't have to use. I haven't released it to NPM because it's primarily done for documentation. You could, if you're interested, you could check it out. Check out the code. Obviously, it's a little bit more sophisticated than this, but the idea is that we can get all of it in one go. We can handle sync errors, async errors, and we can get the error context, which is the error object, with some explanation you provide. This is how it works. Front-facing API, we wrap the function under question, then we can use it in the following way. It's very simple, nothing sophisticated here. You can implement it at home. Yeah, same stuff for async. But can we do better? It's all nice, NPM packages, whatever, but is there anything better we can do? Well, sort of, maybe. We could maybe try and maybe analyze JavaScript in a way and try to see whether there are things that are throwing. And the funny part is that it's very hard to find what is it that can throw in vanilla JavaScript. It's kind of ridiculous. So maybe not. Maybe next time I'm going to talk about some amazing technology that will do some AST magic. Yeah. So today we've learned about the kinds of error handling. There is also the concept of controlled errors, the last one. And of course, we learned about the challenges in error handling. Thanks for listening.